All right, I think this is going to be the last lecture of the year. I'm going to cover two topics, one from the book and one not. The topic from the book is going to be exceptions. You may have done exception handling in C++ and Java. It may be a completely new topic to you. If it's a completely new topic to you, it's extraordinarily important that you understand how to do it. So let's go ahead and get into Chapter 11. The other topic we're going to do is just pulling data from a web page, right? Scraping data from a web page. There's a couple different ways you can do that. There are some excellent libraries for doing that, third-party libraries that you can install. But there are, of course, default methods and classes for doing it as well. So that's what we're going to do. So what is an exception? Well, you've probably seen your program get to the point where it can't run any further, right? We're running and then suddenly it fails. We divided by 0. We tried to open a file that didn't exist. You've seen that exception message before. Well, we don't want our programs to die in the middle. That would be a bad thing, right? You're writing, software that controls a self-driving vehicle. It's bad if that program crashes the computer that it's running on. So what we want to be able to do is to so-called catch those exceptions. Oh, and you probably saw this in Python as well, where we had a try, and then colon followed by some code, and then we had an except, colon, followed by some code. Well, the keywords we're going to use here are try, but not except, colon. Most languages use the term catch. They're catching the exception. So, an exception is any error or condition or unexpected behavior in an executing program. Now, C++ does not necessarily generate exceptions. Sometimes it'll just flat out fail. Just crash the program, you don't have any recourse. But other programs, other frameworks will generate exceptions for everything. Python, C#, and Java. And C++ does have exception handling. It's just that exception handling was kind of invented, bolted on to the root C++, to the root C language. And so, they couldn't go back and, and make the C language behave completely differently, just because C++ tries to be 100% backwards compatible with C. But C# and Java, Python were written after that, and from the ground up they use exceptions. So what happens? You encounter an error. For example, the conversion, the parsing function tries to convert a string to an int, but there's some letters in it and it can't do it. We've been using try parse, right? The safe version of the function. But if you didn't use the safe version of the function, when it encountered bad data, it would blow up. That's why we've been using try parse. So what do I mean by blow up? It generates an exception. And unless the exception is handled, it terminates the program. So each kind of exception has its own object. So exceptions are objects of the exception class, or one of the classes derived from it. For example, system argument exception, thrown when one of the arguments provided to a method is not valid. Arithmetic exception. We fail to cast something correctly. We fail to convert something. There's a math error. Array type mismatch. You declare an int array events, but you should try to store a string in it. Index out of range exception. It's really nice, the languages that do generate this, because in C and C++, you can go straight past the end of the array and corrupt the program, and it may not even fail. It's just going to be running with corrupted data. Or even what's known as a buffer overrun. It can go in and it can modify the source code if it's done very carefully. And if the person knows exactly how to do what to write to what portion of the program. And there are some extremely clever, people. So this language, Java and Python, do throw an index out of range exception when you try to access an element of the array that does not exist. If it's 10 items long and you access item 20, it'll cast that. Throw that. And so on. You try to access something from a null pointer. I saw that one on the slide here. Right. So do read the chapter, but I'm going to kind of skip past most of this stuff to get to the example because we like examples. So the syntax, try, and then some block of code, and then catch, where you specify the exception that you're catching and a good variable name for that object, and you handle it however you want to. You could kill the program, but at least it's not going to print some ugly error message, exception 93 whatever, which kind of reduces the user's faith in you as a programmer. So you at least want to print a clean error, writing to a file, but it generates an exception. You'd want to offer them a chance to to do something else. Do you want to quit the program? Do you want to pick a new file? Whatever. So you have to catch the specific exception, right? We saw a null pointer exception and we saw an array index exception. If this code could cast either one of those, but we only catch the null pointer exception, then if we hit the range exception, it'll still kill the program. You have to catch all the possible exceptions if you don't want the program to die, if it encounters it. So we would have to put 2 catch blocks. One for catching the null pointer reference and one for, the range reference. So the catch statement can catch one type of exception. You have to put a catch block or else it won't compile. And then there's also a finally statement. The finally code is something that's executed regardless of whether an exception was caught or not. So the syntax is really try, do some stuff, catch, do something else, and then finally. Last thing to do, whether an exception is caught or not. Not all languages have a finally. And of course, there would have to be an exception type and a variable name there. So if we had something to do, and then we printed an A, printed 1 there. And then we handle the error, and the way we handle it is by printing a 2. And then we decided that the last thing we wanted to see was printing a 3. Like that. I'm going to mess this up a little bit. Yeah, that's good enough. Then I'll make the change. Okay. So, if it's cruising along and no error occurs, here's what happens. It would do all that stuff. Everything worked great, so it would print a 1. It's going to skip everything in the catch block because no exceptions were caught. So not going to print a 2. And then it has to execute the finally block. So it would print a 3. And you understand that my comments are because I'm not going to take the time to actually write out valid code. What if an error occurs? It would do some stuff here, but if an exception occurred, it would not do this. It would immediately transfer control to the catch block, as long as the catch block is configured to catch the exception that can be thrown here. So it would not print a 1. It would print a 2. Then it would come down here, and it would do the finally, and it would print a 3. This block is optional. You don't have to put a finally. This block is not. If you put a try tag, you better put a catch. Now this try and finally business can behave in ways that you wouldn't even expect it to do. And I'll show you what I mean. What if we had a return statement out of here, right? Everything works great, and so we're going to return. Or everything works great, and so we're going to break, right? We're inside some kind of loop. I'm going to do return, though, since I haven't coded the loop. Everything works great. We're going to return a 0. So what happens? We try the code. We print out a 1. We return a 0. No, wait. as it tries to return, it has to execute the finally. No matter what, it has to execute the finally. If this is a break statement, it would have to jump down here, run all this code, jump back up, and then execute the break. Or before it can return, it has to jump down here, run all this stuff, and then come back and return. So that may seem counterintuitive. You see a return statement, you're used to it triggering immediately. Nope. If there's a finally clause here, we got to do all that, or the code does all that before it returns. All right, let's do some code examples. Yeah, so what? Pick a different directory. That's it. All right, and this is why, by the way, if you want to rename your, your project to Lecture Y. I forgot to give it a good name. I'm going to close the Solution Explorer completely because I'm not going to be adding more than one file, I don't think. Alright, so what kind of code can generate an exception? Well, integer division by 0 is a bad thing, right? Int x is equal to 1, int y is equal to 0, int z is equal to x divided by y, cw console.out.writeLine, we're going to print out z. Alrighty. Can we? Alright, it blows up. Exception unhandled. If we ran this from the command prompt and compiled it for, release rather than debug, then, yeah, it wouldn't just fail with a little message here. The user would get a great big Windows message, saying that the application was, performed an illegal operation and was going to die. So we would want to handle that. Here's what the exception is. Handle divide by 0 exception. That's what we need. So we're going to put this code in a try block. And then we're going to put a catch block underneath it. Stop debugging. All right, so what I'm going to do is I'm going to go ahead and define my z variable before the try catch block. I'll explain why I'm doing that later. That means that I wouldn't define it there. So I'm going to try this stuff. Try, open curly brace, do some stuff, write the answer out. And then catch, kind of like an if-else, right? Anyways, if we have a problem, we're going to say cannot divide by 0. Now this syntax is not correct. I have not put the type of error that we are catching. So, catch, parentheses, divide by 0, and you see it there in the tooltips, and the helper there. Divide by 0 exception, every word, initial capped, variable EX. Why are you giving me grief here? All right. Light bulbs will like this one. I'll show you potential fixes. Introduce constant. I'm curious about this. I'm going to undo it. I mean, I am going to do it, and then I won't. And it didn't change the same thing. Okay, it defined a string up here so that if I wanted to print this out, but I wanted to modify it later, I could go up to the top of the program and do it. Very well, I'm going to undo that. All right. We could ask the user to type in the value, just to test it, right? So, CW, tab, so it says console.writeLine. Enter an integer. Z is equal to, no, Y is equal to console.read line. Except that's not going to work. I have to read it into a string and parse it. So string S is equal to console.readLine. Excuse me, I put a capital S there. I slipped into Java. Lowercase string s. I'm seeing more errors than I'm used to seeing because I usually use an earlier version of Visual Studio. Aha, I forgot a closing quote. And I'm going to make it right rather than write line so that they type their response in the same line. Did I do the same thing down here? Indeed I did. That's why things were starting to look pretty weird. All right. So there's our code as is. But we have to convert S to an int, right? All right, so let's convert that. Y is equal to convert dot int 32, excuse me, to int, convert dot to int 32, the string. Now we're ready to go. Let's run it, and we can type in, 1 and it won't fail. You type in 0, this is kind of lame to just print out Z. We could do, x divided by y is equal to z. It's almost overkill, but let's do it. Placeholder 0 divided by placeholder 1 equals placeholder 2, end quote, comma, x, comma, y, comma, z. Keep hitting that. Should be hitting that. All right, enter an integer. 1 should not fail. Oh, and then yelled at me about my read key. Integers 1. 1 divided by 1 is equal to 1. Pretty awesome. Okay, I'm going to run it again and type in 0, and we're going to see our problem. Cannot divide by 0. Great. We could loop, we could ask them to enter another number, and could you avoid this problem to begin with? Yes, you could use procedural programming to avoid the problem, right? You could check Before you do the division, you know, if y is equal to 0, print an error message. So is this the most efficient way to handle it? Not necessarily. It's a demonstration. However, what if we type in something that's invalid and this command fails? Enter an integer. No way. Boom, it blows up. Format exception. Input string was not in the correct format. Let's do that. We need to catch another exception. So, stop my debugging. You know, up here with the red box. I usually set this to white background, but I'm doing it on a different machine. Okay, format exception, EX. Why EX? I just need a variable to hold it. You don't have to create your own message. You can query the EX object for the message. Console.writeLine EX dot is it just dot in message? Yeah. Get the property, the message property out of it. Let's see what that looks like. If it's not friendly enough, if it doesn't look like something the user wants to see, then we won't print that out. We'll print out something better. We'll print out our own message. Enter an integer. I thought I caught it. Oh, well, I didn't catch it, did I? This line of code is right here. It's outside of the try block. So what could we do? There's any number of approaches, but one thing we could do is put this in its own try block, right? We could say, yeah, try that, and if we get an error, you know, or you could just catch multiple errors in the same block, right? It's kind of up to you as to how you handle this. Do you want to put every risky statement inside its own try? It doesn't always make sense to do that. I think that in this case it makes sense to move this conversion statement into our try. So all I did is highlight it, and I cut it with Control-C, and I come down here and I paste it. Because this is a risky statement, and this is a risky statement. Both of those can throw errors. I'm going to move a couple curly braces to make the code more of a fit on the screen at the same time. I know it also makes it a little more difficult to read, but okay. All right, now when this executes, if it gets a bad argument, it's not going to crash the program. It's going to be caught by this. I'm excited to find out what it's going to print. So stop debugging. Run it. Enter an integer. Input string was not in a correct format. I like that. Maybe we want to tell them something else. Maybe we want to tell them exactly what was wrong. Value was not an integer. Right? So after that message, let's give them a better message. Input must be an integer. Something like that. The other one was kind of programmer techie explanation. They might be able to figure out what they did wrong, but now we're telling them exactly. Except why we use the word integer. We could say whole number, and everybody knows what a whole number is. All right, enter an integer, blah, blah, blah. Input must be an integer. All right, we've handled two different errors. What would make this code even better? Putting it in a try loop would make it even better. Maybe modularizing it so that all of this was in its own method would be better. When I said put it in a try loop, you know, put it in a loop so that they can't get away with typing in bad data. That might be worth taking the time to do. We would have to move all this code, or a vast majority of it, right? We could write some code that would do the conversion in a safe format, right? And it would insist On the other hand, we've done that already, right? We did that with, you know, try parse, and if we didn't get a good answer, then we looped. So I don't think we need to do that exactly. But why not do this? Let's come up here and let's do like something like a while true, you know, some kind of infinite loop. And then if it gets to this point right here, it's great. Everything worked. Otherwise, we're going to, you know, so we can put a break or a return because everything worked at this point. And there's other ways you can structure it as well. Right, like we could set a done flag equal to false and then do while not done. That's, you know, more strictly correct than while true. So let's do that. So Boolean, or just bool, you know, done equals false. And I'm going to put a while not done or while done equals false there. And I'm going to put, you know, a closing brace here before the console read key. It's going to mess up our formatting a little bit. Maybe it'll adjust itself. So while, parentheses, exclamation point, done, like that. Delete the closing brace because we're going to put it down later. So while not done, go to the end of the catch blocks before the console read key. Put a closing brace, and it did format everything correctly. Why are we doing that? So that it will keep looping until the user enters something good. But I put this stuff in the wrong place. I put the while below asking for it. So, right, it would just keep printing out an error message forever or something like that. We need to move this stuff inside the while loop. My mistake. So I'm just going to highlight those. Control X, come down here, Control V. Oh, but my done bool still has to be above the while, excuse me. Go back up here. All right, that's my final answer. Bool done is equal to false, while not done, console.write, integer, string S is equal to console.readline. Try, do all this stuff. If we get Oh, I put that in the wrong place, didn't I?
Yeah, I noticed that. I thought
Yeah,
maybe I
yeah.
was missing something.
I put this in the wrong place. We're not going to yell at them and tell them the integer input must be an integer. I need this to be where we catch it. So I'm going to cut that as well. Cut and paste it here. Right, so we're going to print the error message that the exception carried, and then we're going to print our own version of it. Input must be an integer. We're almost done. If we get past all of this stuff, then we can set the done flag to true.
How do you know what the proper hierarchy for exceptions are? Because I know they're supposed to be from most specific to least specific. If you do it wrong, will that run a compile error?
Right. So the question is, you have a hierarchy of exceptions, and that's very true. These are all subclasses, child classes of the root exception class. What does a root exception class mean? It means that we didn't want to be picky and handle specific exceptions. We can just handle the root exception and it would capture every error. Is that a great idea? No, it is not a great idea. Certainly during development, because it masks problems, right? Any exception in any function that, you know, this stuff calls, you know, would be handled. And when you're doing development, you want the code to crash if there's a problem. You want it to be blatantly obvious that there's a problem. So, we could do this, capture all exceptions, and if we did that, we would not have to have these two sections of code. But notice, this is underlined as an error now. This is underlined as an error now because they're caught in order. They need to be most specific down to least specific. This is the least specific handler. If I wanted to do that, I would come down here and put that down here. Okay, the worst thing in the world would be to catch the exception and not display an error, right? The user doesn't know, the developer doesn't know that any problem occurred whatsoever. I am going to get rid of this. I'm going to comment it out. Generic exception catch anything thrown. Generally a bad idea. Better to list the ones you expect. Now on production code, you know, that software that's flying the plane or driving the car or whatever. I don't know if they would write that in C#, but this kind of stuff does, you know, exist in other languages as well. You might want to do that. Might want to have it like that. So, why? Because you might want to make the code absolutely bulletproof so it can. But you better have some way of handling, you know, the unexpected exception, some reasonable recourse. Are you going to restart the program? Right? You know, whatever. So I'm going to leave that commented out because I consider it poor programming for, you know, for development purposes. Generally, you want your program to die if there's something wrong in development, especially in early development, because you want to go back in and handle all those invalid ways of doing it. And so if you don't develop a framework that would catch, you know, the problem, I think I've belabored it enough. Is this going to work now? We have a while loop, while not done, based on that flag. We ask for the integer, we read it, we do all of this. We could even, if we wanted to, tuck this away inside the try block. Is that necessary? Maybe it'd make it cleaner. I don't know. I'm going to cut those two lines and paste them in here. Not strictly necessary because neither that line or that line is going to blow up. But why not? That's all of the code that we need. We could even move everything from here to here inside a method. Right? And then the try block would just be two lines of code. One would be a method call, and then the other would be done is equal to true. And yes, this stuff can handle catches. It can handle exceptions that are thrown from subroutines, right? From methods. Your methods can also throw their own exceptions. You don't just have to wait for C# to give you one. You can catch some error message and throw your own exception. You can even define your own exception classes if you need to. All right, I'm going to try it out. What I'm expecting it to do is to loop until the user gives us, until the operation succeeds successfully. I like that, succeed successfully. How could you succeed unsuccessfully? All right. Input must be an integer. Enter an integer. All right. So that worked. I ought to print some kind of done message at the end or press any key to continue or something like that. Going to run it again and test out the other errors, right? Because there's two different kinds. Type in garbage, type in 0, cannot divide by 0. It's still asking me for valid data. You know, I ought to tell them, enter a non-zero integer, or enter a non-zero whole number, something like that. Pardon me.
Are you aware of why doubles don't throw exceptions when divided by 0?
Why do doubles not throw exceptions? Somebody made a decision all the way back in C++, and maybe all the way back in C, that dividing by 0, if it's a double, is not a problem, and instead sets it to a very specific value that you could check. Why that decision was made, I don't really know. But you could check. What am I talking about? You know, the students in the lecture already noticed that if we change our values into doubles, like instead of int being x being an int, what if we change that to a double? Is that going to enter any other errors? Cannot implicitly convert type double to int. Are you missing a cast?
You can make z a double and then cast a double into one.
Right, this has to be a double as well. All right, so I changed x and z to doubles to get this conversion to work correctly. And when we run it, it's not going to catch an exception if we enter 0. Instead, it prints out an infinity. Pretty neat. We could check for that value. Obviously, we don't have the infinity, symbol. Check for infinity, C#. Oh, neat, there's two kinds of infinity. There's dot positive infinity and there's dot negative infinity. I certainly didn't realize that. But we could check the result. We could put a if answer, equals positive infinity. Kind of like this. Anyways, you can check for those answers. You can check for those possible values. What does infinity equal in C#? Probably just going to take me to Stack Overflow. So, for fun, I'm going to try that. After we get our answer here, after we do our division, if z equals double dot, or is it infinity? Parentheses in parentheses, then console dot write. Oh no, divide by 0. This is a little bit different, right? We're handling the error in two different spots. Would we want to do that? No. We might want to catch it and throw our own exception. We might want to throw our own divide by 0 exception. But let's give this a shot first. Else, print out the answer. Let's run it. There were build errors. What did I do wrong? Okay, guess that's wrong. Guess we're going to pass z in as a parameter. Excuse me. If parentheses double dot is infinity and we're passing z in to be checked, it seems to work. If that's true, print an error message. Else, do the right line. All right, enter 0. Oh no, divide by 0. So, we thought we were being clever. We thought that we handled the error correctly, but we did not because it didn't loop, right? We wanted to jump to the divide by 0 exception. Let's see if we can throw that. Instead of printing out, oh no, divide by 0, I'm going to do throw divide by 0 exception, and that's probably not going to work. Throw new divide by 0 exception. Is that going to work? Oh, I need parentheses after that because it's a class. So, regardless of, since this does not generate an exception, if we divide a double by an integer 0, or a double by a double, we're going to handle that ourselves. We're going to check to see if it's infinity. Now we're back to some good working code. Enter an integer. 0. Cannot divide by 0. Right? Now we're not seeing that infinity symbol. We wouldn't want to do math on infinity. We would not want to apply infinity amount of thrust to your thrusters, whatever. All right, I'm pretty happy with how this turned out. Let me zoom out a little bit. Maybe you can see it all, maybe not. Probably not. You're going to have to check the notes for it. I'm going to rearrange this, delete that comment.
So if you have that catch block, that's a divide by zero exception, and you throw that new divide by zero exception, it goes to that one.
Right, exactly. As long as we have a catch block configured to catch what we throw, it doesn't matter whether C# threw the exception or whether we did. And we could put this throw in a method that we called, and it would still work. It would trickle back up. Right, if we have some method up here, static void oops x is equal to 1 divided by 0, you know, like that. And then we call oops down here inside our try block. I'm going to delete this or comment it out because it's silly. But here we have a little method that will certainly generate an error. Fine. Int x is equal to 1. X equals x divided by 0. Now, all right. So we have two ways of handling this. We could put this code in a try-catch. We could handle it here. If we don't handle it here, then it gets caught down here. So they trickle back. They go up what's known as the call stack. If it's not handled here, the exception will be passed back from this method to whatever called it. And if it's not handled there, then it'll be passed back to the next one that called that, and so on, all the way back to the driver code, all the way to main. It has to be handled somewhere. If it's not handled somewhere, it's got to be handled in main. If it's not handled in main, then it'll stop the execution of the program. Going to get rid of that. I'm going to scroll up and down, and we're going to be done with the lecture. Yeah, maybe I'll leave this here.
No scraping?
Yeah, we'll do the web scraping. Okay, this would throw an exception, which, if not handled in the method, would be passed back to the calling code to be handled there. All right, so I'm going to scroll down slowly. Here's some code. Here's the main method. Here's our catches. There's our read key. That's the end of the main. Alrighty. All right, to the next topic. Web scraping. I'm going to disable all this code from working by making this done equal to true, right? Because if done is equal to true, it's not going to even enter the loop. Web scraping is just opening a web page, an HTML page, and when the results come back to you, storing that in a string, and then you have all that text. You can play with the text. So for example, my silly little example, going to be one that we also use in Intro to Python. Where'd it go? Where'd it go? This one. Welcome to the Beans R Us pricing page. Special offer. The current price of coffee beans is equal to that. And each time we refresh it, we get a different price. So we might want to wait until the price drops below a certain value. We might keep looping. Now you don't make it where you check the web page once a second or something like that. The people, the webmasters for that would consider that, some kind of denial of service, right? You're not supposed to be hitting a web page that fast. You certainly don't want a whole bunch of applications hitting a web server that fast. So we would make it, wait once a minute or something like that. Now I made it, this is kind of a long URL, so I made a short URL to do it. It's going to be tinyurl.com 123beans 456. So tinyurl.com / 123beans 456. Hit enter. Pulls up the web page. You're probably used to the idea of URL shorteners, you know, right? You post a long URL on Twitter, it shortens it, right? Because you only have 144 or 288 characters, you know, you want 100 of them used up by a long URL. So how do we do that? We're going to use another class. All right, so our web scraping. Yeah, maybe we'll put in its own method. All right, static void get price. And we're going to accept a URL. And then we're going to return a value, except if we're going to return a value, it's not going to be void, is it? And down here, we're going to define the URL, and then we're going to call get price, and then we're going to print it out. So string URL is equal to, I should fully qualify it, http:// tiny, T-I-N-Y, URL /123 beans 456. Or was it just bean? Don't remember. Let me go look. Yep, with an S. Now, double price is equal to get price. All lowercase is how I made it. Get price. Pass in that URL. And then print it out. Console.writeLine. Coffee bean price per pound equals end quote plus price, or whatever, right? Use a placeholder, format it nicely to 2 decimal places, put a $sign in front of it, whatever. All right, I'm going to test this, just, you know, test early, test often. All it's going to print is 0 because we don't actually have any code that opens and scrapes. All right, so coffee bean is equal to 0. It's annoying me that I don't have a, you know, program done or press enter to quit or anything down at the bottom, so I'm going to go do that. Console.writeLine done. Press enter to quit. Scroll back up. Yeah, run it. Yay. Heck, put a /n in front of it. Okay, so we're coming back up here. Here's our code that calls our code. Here's our code where we're going to put our function. Excuse me, our code that opens the web page. And the code is kind of long. It's going to be a lot of typing, but fortunately, you know, hopefully the auto-filling stuff will save us a little bit. So once we get here, we're going to need an HTTP web request object. So HTTP web request, and we're probably going to have to add a package or using in order to get this to work. Request equals, that's enough. We got to get that to work first, right? quick actions. Add system.net. So we could come up here and do using system.net.star. Is that going to work? That make the error go away? Seems to. Well, I had it fully qualified here. I'm going to take that away. All right. Think I got it. I'm going to move static oops out of the way. You don't need to do this, but I want those using statements to be. So I'm just going to push this down to the very bottom after the end of main. You don't need to do that. I just want to have both of these pieces of code, right? That is necessary for that because that's part of this library here. All right, now we need a web response variable as well. We're going to make a request, and then we're going to pull our response out of the result. HTTP web response. And we're going to need a text reader. Just like we were reading from a file, except this time we're going to read from the web response. Text reader. All right, so those are our three goodies, except text reader is not part of the same thing. Remind me, system.io. So I'm going to go back up and add a system include
it's weird
using
that system.text and system.io aren't the same thing.
right system. Well, net. You might want to do IO because yeah, the question is why aren't these in the same library? It's because text reading is something that you would do more than just over the network. Now, making this a sub-library, putting all that in system.io would make sense to me. But
no, I meant that system.text and system.io aren't the same.
Yeah, exactly. What happens if you do this? That's horrible. That can't possibly work. Yeah, all right. So using system.io. That gets our text reader. Run it just to make sure. All right, no errors so far. We are going to create our request. Request equals. Now this says that we have to cast it. I'm going to try it without casting first. Web request. Why would we need to cast it? Let's find out. Dot create parentheses, and we're going to pass our URL in. Not in quotes. URL in quotes. Cannot implicitly type. We have to cast it. Well, what do you know? Okay. It's of this type. Save time. I'm just going to copy that. I could type it out. So parentheses, HTTP web request in parentheses. All right. HTTP web response. We got to pull the response out of it. So, I forgot my S in response, excuse me. Response is equal to, and I better cast it as well, HTTP. Not sure why they didn't make these methods just return the correct object, but whatever. HTTP web response space, and we're going to pull our response out of the request that was returned. Request.get response, parentheses and parentheses. Then we have to make sure that everything is okay. We're going to check this response to make sure it's okay and that the content length is greater than 0. So if request, if response dot if response dot status code. So if response dot status code equals HTTP status code dot OK. So clearly it's an enumerated type. Excuse me, HTTP static code dot OK. Oh, and cute, I'm going to have to import another library.
Status code or static code?
What is my misspelling? I'm not seeing it yet.
Because I put in HTTP status code.
Oh, okay. Why did I type static? Thank you. All right. So if response.status code equals HTTP status code dot OK, and we have another case to handle, and the length of the result is greater than 0, response.content length greater than 0. Now I'm sure there are a great many different types of HTTP status codes. Don't type this unless you're really curious. HTTP status code dot bad request, bad gateway, conflict, all these things. Not found. 8 million different errors. Request URI is too long. Nah, just leave it like that. So if all that stuff is good, then great. I'm just going to write a message here. Console.write line URL plus space quote read. We're obviously going to do something more than that, but I'm eager to see if this works. Oh, I hope this works. Unhandled exception. The remote name could not be resolved. Tiny URL. All right. Stop the debugger. Is it HTTP? Is it www.tinyurl?
I put, well, maybe mine will work. Let me check.
HTTPS. tinyurl.com. 123beans456. HTTPS.
Let's try the actual website name. That works.
Just leave off the HTTP and that worked for you?
I put in beansrs.appspot.com/isolate, all that good stuff.
Sure. Okay. Maybe since it's redirecting it, it wouldn't work. Sure takes a long time for it to time out, but that's kind of good. You know, the little spinning wheel that you get when your browser's trying to access something. All right, stop it. So that's not working, so I definitely need the actual URL. Sorry, it's a lot of typing. Tell you what, it's not a lot of typing if you go to, right, tiny URL /123beans456. Excuse me. tinyurl.com/123beans456. Get that, copy all of that, and we're going to paste that into the URL. So down here, string URL is equal to that. Positive you're going to type it in by hand, right? www.beans-r.appspot.com/prices-loyalty.html. Hope this works. Yep, it read it. We're curious about what it contains. We need to pull out the response as a string. So let's get the string out. Then we'll print it. string, whatever, text. I'm in the wrong place, aren't I? Yes. Go back up to our method up here. It's kind of interesting that C# took a different concept than Java. Java, exceptions will be thrown if this stuff fails. Here we have to check for the status code. I don't have a preference for one over the other. Checking for status codes is kind of the way my brain works. But, you know, I was originally taught procedural programming rather than object-oriented programming. All right, so string text is equal to well, we have to create a text reader to pull our data out. So, text.
Didn't we already create one?
Oh, yeah, you're right. We did create one here. So, excuse me. It's just reader. Come back down here. Reader is equal to response dot. Oh, reader is equal to new. I've done that. But we got to cast it. Maybe creating the reader ahead of time was a bad idea. I'm going to follow my example exactly. So reader is equal to new stream reader, parentheses, quote, response dot get response stream, parentheses, in parentheses, one more closing parentheses, semicolon. What does this return? Just returns a stream object. Well, leave that alone. Once we get that, we can use the reader to read the file, to read the HTML we're pulling back. String text equals reader dot read to end. Parentheses and parentheses. Just read everything on the web page. And let's print it out. I think instead of writing that, I'm going to read out the text we got. Print out the text we got. Write it out. So here's our story so far. Let's see if I can get the entire method on one screen. Yeah, barely. And I'm itching to run it. All right, here it is. Here's all the HTML. If you're familiar with HTML, what is that? Well, if we went here and we right-clicked and we did View Page Source, we'd see all that. I'm not going to explain HTML, but what we're going to see is that if we looked for a $sign, we would know what we needed to extract. So we could go for a $sign, and if we were pretty sure that the price of beans was always 4 long, right, then we could just do a substring starting in that position and grabbing 4. And maybe that's not how we want to do it. Maybe we would want to pull the data in and then go up to the point, right, where the open brace was, to be doubly safe. I'm going to make it kind of simple. We should probably have an else, right? It says invalid URL or something. So else, putting that under the if statement, of course, if the response was invalid, console.writeLine parentheses URL plus quote space could not be opened. Tell them what's wrong. And then return a 0 out of there. We're going to return a good value eventually, so we'll be able to delete that. Okay, so text is our string that we're going to search, and we're going to use index of to find the dollar sign. This is assuming that there's only one dollar sign, right, in the file. So we could make this a method, another method. That would be more, modular. I'm just going to code it here. So int start is equal to text dot index of parentheses. Let me look for a dollar sign. And we're going to start at string position 0. I am going to try to do a good job of this, right? We're going to look for the dollar sign, then we're going to look for the closing brace after it, and that way we're not just assuming that our price is 4 characters long, right? What if coffee spikes and it's suddenly, in the hundreds or thousands of dollars? That's useful information. And let's do int end, and I don't know why I'm capitalizing start and end, except I'm looking at an example here. Text dot index of, whoops, spelled that wrong, index of, quote, open angle brace, and we want to start, we want this search to begin at the dollar sign, right? Or one past the dollar sign, because we don't want to find the first thing in the string in the document. We want to find the first string that occurs after the dollar sign. So we're going to put start here. Out of curiosity's sake, before I go further, I'm going to print those values out. Console.WriteLine, placeholder 0, placeholder 1, end quote, comma, start, comma, end. Just because I want to diagnose the problem if this doesn't work. Build errors. Something up here. Oh, not every path, because I moved the return statement. Not every path returns a value, so return 0. We're going to fix that. We will parse the response once we finally get what we want. Here we go. The dollar sign is at character 250. The position of the angle brace is at 255, wherever that is in it, right? So that's 250, 251, 252, 253, 254, and that's 255. We can use those two values in the substring method to extract only that text. So string S price, right, for string price, or price S, something like that, is equal to text dot substring starting at the start position. And what is our length? Our length is the end minus the start. I almost would prefer to calculate that ahead of time. So I'm going to do int length equals end minus start. And then price is equal to text.substring from the starting position going out that many characters, length. Now let's print that out. Just a sec. Let's print that out. Console.WriteLine, parentheses, quote, S price equals, I think I put prints. space end quote plus S price. I'm going to run it, and then I'm going to do walkabout for the students in class. All right, so S price equals $4.42. I don't want that dollar sign in it. I've got a problem here. I want to skip the dollar sign, right? Because if I try to convert something with the dollar sign, so I'm just going to do a +1 here. My start plus plus, right? Skip the dollar sign. What if the dollar sign isn't in there? What if there's no closing angle? We ought to do better programming than this, but you can handle all that stuff. You know how to do it. Check the return value of text.indexUp, make sure it's a valid response, that kind of stuff. All right, we're practically done. All right, let's get that data out with try parse. So double price equals double dot try parse parentheses the string we're passing in, which is S price, comma, out space. That's not right, sorry. We do need the price variable though. So double price, semicolon, and then double dot try parse, S price, comma, out price, semicolon. And I'm filling this with all sloppy code because I didn't check the result of try parse. You know, I didn't make sure that it was working. I would leave that as an exercise for you. This is the simplest example possible. I'm going to move this console.write line and actually print. Or why don't I just copy and paste it, right? Console.write line price equals placeholder 0 colon C, print it out as currency, end placeholder, comma, price. Alrighty. Obviously, we have a lot of print statements we don't need. The price was 4.22. That's what I need to return rather than 0. And I could have printed it out down here correctly rather than, you know, print it here. So I'm going to remove all of my print statements, or at least comment them out, because it's making the code messy. I'm curious about this error, this suggestion here. Not getting it, doesn't seem necessary to me. Okay, so down here, after we call get price, coffee bean price per dollar sign equals placeholder 0 colon C, end placeholder, comma, price. Like that. All right, I think we're good. Like I said, code does not do any good error handling.
What would be the general purpose of web scraping?
What's the general purpose of web scraping? Well, how does Google know what web pages have what text? So Google written spiders called web spiders that'll search a web page, pull out all the text, save that somewhere, look at all the links, and then visit all those links to find out what they link to and what they link to. And then the more sites that link to a website, the higher in its rankings they go, or the more the advertisers pay, right? That's one purpose. Another is doing exactly what we're doing here. We're just curious about something. We're curious about, you know, we need to know the price. and we don't want a user to have to sit there by hand refreshing a page to get it. Or you're writing a Facebook client, right? You could scrape Facebook for all your information that you want yourself, you know, and only display the messages without putting a, you know, the sidebars and stuff like that. That makes sense?
Yes.
Okay. All right, I think this demonstration is done. Oh, it's still saying coffee bean price per pound. I've forgotten that one key component, which is that after we get a good price, we better not return 0. We better return the price. And if the URL cannot be opened, rather than return 0, which looks like a valid price, I would want to return some kind of value that was invalid, right? Some kind of sentinel value. And then I'd want to make the code that called it check for that. Or I'd want to make this throw an exception, you know, all sorts of error handling. All right, think we're done with this. All I could do to fix it, to make it prettier, would be to remove the right lines. I could add error handling. It would clutter it up. You would not tell an end user that you skipped error handling because it cluttered it up. All right. Hope that was good. This will be in the notes. And I think this is the last lecture, so I hope to see you in other classes.
Well, unfortunately, that'll be it for me.
Yep.
But it's been fun.